This year, of course, we've not been able to go to NAB or IBC, which is a shame for me. I love meeting people there. One of my favourite conversations regularly at NAB and IBC is with Lewis Kirkaldie from Cinegy, and I'm delighted that he's with us today. Hello, Lewis.
Hey, Dick, how you doing?
I'm great. I'm great. So, first of all, Cinegy. Just in the three sentence answer. What are you about?
Oh, making great software, running in the cloud, and I'm out of the third one. I wasn't ready. Excellent tea making. There we go.
So, your primary business then is in developing customized solutions, as you say. It's software, it's cloud solutions. You're in the business of developing and tailoring solutions for people.
Yeah, I mean it's a market and it's a process that this industry has worked hard understanding, because there's always pressure for that wonderful acronym COTS, custom off the shelf, or customizable off the shelf stuff, and then there's bespoke solutions. So you're always walking that fine line as a customer of such solutions. You want the benefits of mass production, the Henry Ford's any color as long as it's black type benefits. But at the same time, you absolutely want it to be that perfect shade of black and with exactly the right number of wheels and axle capacity for your business. So there is always that balance, and part of the innovation of industry and of Cinegy is working out ways that you can do the bit of cakeism. How can you have your cake and eat that? How can you have a black Ford but with go faster flames down the side?
So it's all about customization. It's all about finding that point of balance between the bespoke solution and the cheap solution.
Yes. I mean, you need to find a way to get your business to have a very tight-fitted. It's how to buy a custom an off-the-shelf suit that looks like it's custom fitted. So one of the enhancements that we try to make sure you can do with our software is that we leave customizable configuration points that mean that you can modify what's happening while still being in that kind of central happy zone. That means you're on the same core software release as everyone else, and when a bug fix goes in for one customer, it goes in for all, and when a feature is added for one customer, it goes in for all. You want to be in that happy groove, but you still need a way to kind of express your business's independence and unique requirements. And actually, there's been quite a lot of improvement in that field in the last decade, and accelerated much more recently in the last few years, as people work to move in the cloud more and more. And you hear the buzz term from a couple of years back that's still echoing around DevOps, development meshed with operations, that seems to be one of the solutions that has dropped in as a way to try and manage that complexity, manage that customization, and manage that software consumption and cloud consumption and virtual machine consumption, and how to find a methodology for working with that without just tying yourself in a huge knot. Because as you increase complexity in any system, you also increase the inherent instability of that system. So managing complexity is a mechanism to regain stability.
What we're really talking about here is customization of software tools. Now, is that something you do as part of the original system supply? Is it something the users do as they understand their own workflows, or is it a bit of both?
I think it's absolutely a bit of both. I think the critical factor is that someone can. So whenever we're looking at mapping out systems and mapping out a delivery, you have two classifications of problems that can be solved with a workaround, and problems that can't. And the most important problems to address early and to address quickly are the ones that do not have a workaround. The workaround may be painful, it may be Byzantine, it may be unhelpful, but if there's a workaround, you can still set sail off into the ocean. If you are completely blocked, there's nothing you can do. So a huge amount of the effort that we put into our software and into the way that we work with customers and customize things is we make sure that there is always that release valve of, okay, well, what can we do that means there is a workaround? And that workaround could then be, actually implementing the customization as needed, or doing something manually, or it can also be Cinegy being commissioned to take care of some things because the customer doesn't have the skills, or similarly, it could be that the customer can do it. So for me, the who does it is very much secondary to the can someone do it, and that's something we work very hard, and is something that's really great about software, is that you can have those kind of configurability and flexible connection points. That's much harder in a shipped product that would be physical. And one of the great benefits of the cloud is that you've got the ability to hook in all sorts of pluggable parts. It's much more like playing with a big set of virtual Legos, and you can build a stable or build a rocket ship.
Yeah, that's interesting, especially the idea that there are problems you can solve, you can develop a workaround, and problems that you can't, that you've got to go off and find something different for. But the broadcast engineer is new to all of this. How are they going to aim themselves at the right solution through customization if they aren't really familiar with the whole software only solution business?
Yeah, I mean, it's the great change that we're seeing people have to go through. And, the days of needing to know how to switch out some linear heads on a VTR are really only for engineers working in archivist areas now, trying desperately to digitize tapes. And it is one of those things where, in IT, which is my background, is you kind of you go into it knowing that the textbooks you may be currently studying will need to be thrown in the shredder in 5 years' time. What you're learning right now has a very short distance of knowledge importance, and we're seeing that more with broadcast engineers, which is the frequency of skill changes is accelerating in a way that it has done for IT people, and having to drag them along. So skills now that people, I believe, will be looking for as they look to recruit or bring into teams broadcast engineers is the ability to understand what Git, the source repository system, is to understand what virtual machines are and how to log into the Amazon console or the Azure portal. These are skills that unfortunately need to be adopted and learnt. And the good thing about those skills, which is helpful, is that you don't need much more than a laptop or a computer and some time to pick these skills up. There's a huge amount of information out there to be taken. It's quite a democratizing influence that you can access open information as to how to use all of these cloud platforms, how to access open source software and platforms like GitHub and GitLab that work to power all of this stuff. You no longer are restricted by the ability to have a big electronics workbench and $100,000 deck to try and take apart to see how it works. So it's a huge shift, and I don't want to underestimate the challenge that this is for people that have spent decades learning an incredibly important skill such as broadcast engineering, electronics. It's a huge ask, but unfortunately, it's one that I think is likely inevitable.
And of course, it's important that we don't forget those fundamental skills. We do still need a fresh picture every 40 milliseconds, whatever
Yes.
happens. So the fundamental broadcast engineering is still there.
Yeah, I mean, you almost see, and this is kind of anecdotal, but SDI as a technology allowed a great deal more people to use broadcast technology because it was so pluggable and so easy to use. And you can almost identify people that had to work with composite signals, then grew up in digital signals, and then come back in. It's people that have got the deeper understanding of the technologies are the ones that I've seen having some better grasp of how to adapt to this new world. People that understood it wasn't just a cable and I plugged it in and it just worked. I feel those people have almost done a disservice by having it that easy throughout that point. And people that remember that some of this stuff used to be a lot harder are able to adapt a lot better, because whether or not you're someone that's got an IT background or a broadcast engineer that's had to troubleshoot an incredibly complicated composite broadcast chain where his cables weren't the right length, those skills transfer. And so being able to logically troubleshoot something and eliminate things, almost Sherlock Holmes style, is a skill that does transfer from this older generation skill of broadcast engineering the traditional way, breaking an oscilloscope out and checking how long some cables are, and seeing where you've got loss and knowing what a vampire tap is. Those things are actually baseline skills, like learning school level maths, that actually can very much stand you in a great deal of stead. And I would actually very happily work with a disciplined broadcast engineer that knows how to describe their problems and describe what steps they've taken to eliminate, document, and verify the nature of their problem. That's more helpful to me working in Cinegy than someone that knows what PowerShell scripting is and how to code some C# that can't describe the nature of a problem effectively.
Yeah, that's a very interesting point. Very interesting point.
Going down a strange avenue.
You mentioned earlier DevOps, and this is
Yeah.
a buzzword of the moment. So, just explain as clearly as you possibly can, and I know that's a challenge, what DevOps is.
Well, I mean, first of all, it's a kind of mishmash of words, I think, generated by hipsters to scare the current generation of senior management into ignorance and fear. So, speaking as someone sporting a beard that is now going slightly grey, and coming from an IT background, I will admit happily to having been somewhat perturbed by this phrase and my lack of understanding of what it actually meant, because it popped out there in the zeitgeist. And I think everyone almost goes through this. It just depends whether they admit it. They're like, what on earth actually is that? And do I need to care? Because partly these things pop up and then disappear again before you ever get a chance to get to grips with what does this really mean and what does it mean for my organization. This is one of those ones that falls into the category of actually being important. And I went off and actually did try and dig into this some years back to be like, what does this mean? This is actually from my cast of people, my creed, my technology background of being a developer and sysadmin, and even I was somewhat confounded by this. And I mean, at its fundamentals, it really is just someone went, oh, cool, well, let's just take the labels we give to the people we call developers and the labels we give to the people that we used to call sysadmins, but we'll call them operations because sometimes they get called operations, and we'll just crush them together and we'll say, you are now the same people, you are DevOps people. And I think I don't know who ever will have coined the term, but someone realized if you actually look at what happens in successful organizations, what was happening naturally is that you would get people that would cross over from being an operations person to being involved in development, or vice versa. Developers would get fed up with the slow pace or misunderstanding of people that work purely as sysadmins or operators, and they would start reaching down into that space. And so I think first of all, it's a label of what people have seen naturally happening in the real world. And then people have gone around to try and classify it and codify it and describe it retrospectively to try and say, well, what is this that's happening that's working quite well? So, I mean, what's really hilarious is I had no idea what this was and I had to look it up until I then realized that I had lived this. I joined the BBC working in IT. I was a sysadmin. I worked as a server engineer for 8 years, and then converged into doing stuff in development and broadcast. So I realized that actually I am a DevOps person, but I never even realized it. And I'd done it before anyone labeled it. So I think the most important part of it is it's understanding that what needs to happen inside successful organizations is that people shouldn't just be categorized and put in that silo and bucket, saying you are operations, you will work on software rollout, you are development, you will work in writing software, and you are testing, so you better not write any software, etc., etc. It's really important that actually people cross-pollinate between their groups and actually even sometimes work in both groups to get the best results. And what we've seen happening in the world is that when people do add this cross-skilling, productivity goes up, but also things that work well in development, for example, things like the Git source control system, work really brilliantly in operations. There's no reason why configuration files for a playout server, an operating system, a web server, there's no reason why those things shouldn't live under source control and version control in exactly the same way that source code for a C++ program does. So you see now, whenever we in Cinegy Professional Services work with customers, the first thing we look to start with is like, well, where is our Git repository? Are we working on open source public stuff in, say, for example, GitHub, or are we working in private repositories that the customer needs to provision? Because the idea now of trying to work with configuration files and not having them under version control and not having that continuous documentation of, line 74 has been changed to now point at the production SQL server. Not having that now feels like a very retrograde step to have to do in operations. But many organizations still won't be using such technologies for containing their configurations, and certainly going back 4 or 5 years, it wasn't the norm at all in operations. It's something that's evolved forwards. It's got to the point now where we actually hold all of Cinegy's manuals, and all of our documentation team work natively in Git, because actually that's pervaded through to our documentation team. So that's kind of DevDocs, if you want to try and merge two more words together again.
So this is a bit of a shift, isn't it? This is the traditional broadcast architecture. You specify what you wanted, you went out, you bought it, you bolted it into a rack, and you poured concrete on it because it was never going to change. The next phase was to have software-centric products, but effectively working the way that traditional legacy products worked. And now you're looking at a much more fluid software model, something that is continually evolving. I can imagine people are slightly scared by this concept, and things happening under the hood that they don't know about.
I think not only are they slightly scared, they're rightfully scared. You nailed it there, Dick, when you said it's continuously changing, and that is one of the greatest benefits, that simultaneously is one of the greatest deficits of moving to this model. It makes reaching stability much harder, because previously with a plant of broadcast kit, it was much more, it was referred to as the broadcast chain, and actually you could pop in and take one link out of the chain and replace it, and the rest of the chain didn't need to know anything, and no one really needed to worry about that, and it was possible. But in software, it's no longer a chain so much as a circuit board or a knitted jumper. It's very much harder to reach in and make specific changes. It isn't a linear flow from input to output to input to output. These things now, with the power that comes in being able to add in much more complexity, much more decision points and branching, it becomes a much more like a tree. The broadcast tree just branches off in directions, and so new methodologies are required to actually control and contain that level of change and change management. Just to throw in a classic line from a Marvel comment, with great power comes great responsibility. This is something Spider-Man struggled with, but it was true. And this is where patterns of work, which is what DevOps fundamentally is, it's a way of teams working, can help, because by putting more control and visibility around your configuration and documentation of what your project and what your system is trying to do, you gain greater insights into it. And these things become self-reinforcing. So when you start working in something like Git to control your documentation and your configuration, you then find yourself no longer reaching for example, I have a Visio document in a Git repository, and if I want to make one small change to a label, that change is invisible in the repository, because it just says this Visio file changed from here to here by 5 megabytes or something. And you actually see team members you've seen again a rise of ASCII art, of just drawing out block diagrams with equals and dashes, because when they change that or make a label change, actually you can see in a diff, a text-based diff, like, I can see this bit changed to this bit in a way that's impossible in other files. So you actually even see almost retrograde steps where people go backwards from more powerful tooling like Visio into stuff that seems to have fallen straight out of the 70s and typewriters, with building up boxes and flowcharts out of ASCII symbols. But it's the kind of strange emergent behavior that is practical. Humans, like water, find a way through the cracks and a way to make it work still. So it is an incredibly complicated system, and watching people figure out how to manage that is really interesting. And one of the other tools that DevOps brings is if you've got all of your configuration under version control, then with the powerful tools you get these days in the cloud and with virtual machines, if you're not physically connecting things in the first place, there's nothing to stop you saying, gosh, I'd like to make a change, but I won't change the actual system that's running. I'll just duplicate it. It's the software engineering equivalent of the Xerox machine. We're just like, well, we'll just photocopy it and then scroll on the photocopy with the change we want to make. And if that looks good at the end, we'll actually just use that as the new master. And we'll just forget about the thing that we had over here. So along with DevOps, that's one of the lovely terms that there's families of these things that all nestle together in the zeitgeist. And so along with DevOps, comes continuous integration, continuous deployment. And another term that I heard for the first time, again, only 2 years, even though we actually do this, is the concept of immutable infrastructure, which I found a fantastic term, which means that it's the software version of your pouring of concrete on the hardware when you've got it right. You define all the software, you get it working, you then effectively pour it in concrete, and if you wish to change it, you make a new one, because at the end of the day, photocopies are cheap, so to speak. So never change the one that works, and just spin up another clone.
That sounds like sensible advice anyway.
Yes.
Never change something that works. But I suppose the next question then is, how do you manage that? How does the chief engineer, if we have such thing as chief engineer, manage it, know what's going on, know what needs to be preserved, and what is going on inside the DevOps team?
Yes, absolutely. So there are various tools that have risen up of darlings of this change. So, along with the label and the term of DevOps has come a tool people will have known, such as Slack. Slack was the darling of DevOps, where people would join channels. Again, it's just a rebranding of the concept that was IRC before, and again, back with people with modems and ASCII. This is the reinvention of the same stuff with different decoration. So you have your team group messaging solution. Slack was one of the ones that caught the early wind for this, but Microsoft have followed up along with Teams, or you have open source alternatives such as Mattermost, or as we still do a huge amount in Cinegy, just classic Skype gets used a huge amount because it's just everyone's got it in the company, and that's where the momentum is. So you have a team communication channel is a critical element of working in this way. Then you need a version control system that's solid, and it's not just about how do I keep these files under version control, which we've had tools for with things like SVN for quite a long time, Subversion. But Git marries a powerful version control system onto incredibly impressive portals that actually help manage the workflows of merging disparate changes. So when people talk about things like Git is only half as powerful without tools and portals such as GitHub or GitLab and Bitbucket, these things that help people manage contributions, changes, understand the impact of merges, test merges with continuous integration services, which is another critical tenet. If you're writing software, there's always the classic case of it works on my machine, but you need a continuous integration system to actually have that source code compiled away from your machine where it works in a clean environment, tested through a few different iterations, built a few different ways to get that green check mark of all is looking good. So there's a lot of collaboration goes on, and a lot of the collaborative partners in this effort these days are machines, and not in an AI form, but just heavy lifting form. We can have a continuous integration server in Cinegy, attempt to recompile the software we've committed 8 different ways, and then run through 100 tests quickly. That requires no intelligence on the machine's part. It's just doing what you told it, but it's an excellent repetitive task machine as a computer. So you bind that in, and then another very important part that is newer, and we haven't seen things like this previously in the same way, is with the rise of virtual technologies in the cloud, where no one, there is just a massive, effectively limitless pile of resources available for you to use. You just need to tell it what to do. The tooling for the telling it what to do has risen up and improved much more dramatically. Things like Slack and Teams are just reinventions and improvements of what's been before. But tools like Amazon CloudFormation or HashiCorp Terraform, which is a favorite of ours, are tools that rise up to meet this space in a way, because the problem didn't exist in the same way it did before. Before there were virtual machines and public clouds, there wasn't this driver in the way there is now, whereas there've always been a need for teams to collaborate or software versions to be under control. So these tools that form these building templates, the blueprints of the cloud, are the critical, most new component. And when we work with organizations and engage with customers, these are the parts that people often have the weakest in-house skill sets with, because they really don't have much of a history, much of a precursor behind them. Most places have moved beyond email into instant chat. They've had some kind of version control systems for years. They have engineers that might be cross-disciplined, but it's relatively rare for us to go in and find a customer has some kind of templating and continuous deployment tooling in place that allows them to, that's required to achieve only change on a copy type workflows, the immutable infrastructure. If you have your entire deployment of your software solution from operating system through to management metrics, log rolling, and then the actual software that, say, Cinegy makes, if all of that is under a scriptable deployment, then your cost to reproduce the environment, the most expensive part normally is the people doing it. So if you can offload that to someone supervising a script running for half an hour, suddenly that ability to make a photocopy and scribble on the photocopy to see if that change looks good becomes something that just wasn't, it's affordable in a way that was completely impractical previously. So you see the greatest change when something that was impractical or unaffordable previously becomes affordable and practical. So going to a customer and saying, actually, if you want to try and add some whizzy new feature or adapt your business logic to work in a way that you think would be profitable, but you don't actually have hard evidence for this, the barrier to entry by using DevOps, by using continuous deployment systems, integration systems, and version controlled configuration and description of your environment, those tools suddenly mean you can actually take a test run of your concept and see if it works out. You can decide that you'll gather data through implementation and effectively gamble an hour or two of time to see how that works out, rather than what would have been a much more sensible broadcasting and engineering approach previously, which is effectively sketch it out, design it, do the mathematics to work out, will that bridge spar hold, and then double the cost of the bridge spar for a safety factor and do it. This way around allows you to be much more relaxed in the careful architecting of things. Certainly if you're looking at, well, let's try this new storage system, or let's try something from a known good base and move forwards. I think where we see people struggling is where they jump in both feet first and don't have any form of care for how to carefully iterate this. If you change 8 things at once, just as that would have scuppered you in a traditional engineering model, it scuppers you in software as well. So actually, implementing a solid system of understanding the process that you've got and knowing where you are to map where you'll go will help you. But with this tooling, it means that if you do it properly, you're less likely to accidentally blow off a foot. And also you can just keep throwing a dart behind you blindly, and eventually you'll hit the board. There's an element of that as well. So,
but there is a great deal of traditional engineering thinking behind it, though, that you only change one variable. You move stepwise so that you understand what is going on.
Yeah, absolutely.
It is the great advantage then that it does allow you to prototype, to try new ideas, to develop new services very much more quickly.
Yes, there's a fantastic phrase. I can't remember who we first heard it from. it must be like 6 or 7 years at least now that I heard, and it may have been like Microsoft talking about this, but there was this concept within software engineering of fail fast. It's like, don't fear failure,
Yeah.
only fear failing too slowly. If you want to run into a wall, run into that wall at full speed so you can dust yourself down and go off and run, again. So with a lot of these things, you could spend 2 or 3 days trying to work out if something is a sound step to make. But actually, if you've got a safe, inexpensive way to actually just say, I don't know, it's 50-50, let's just see what happens. The business case can stand up for itself in that direction as well. So failing fast is an ethos that, when carefully controlled, can be really valuable. I mean, the important thing isn't that you run into the wall, it's that you know why you ran into the wall and how you'll not do it next time.
That's a brilliant place in which to end. Lewis, thank you very much. It's always a delight to talk to you. I always learn a vast amount. Thank you very much, Lewis Kirkaldie from Cinegy. Back to the studio.